Today we are doing a hard problem 3699, number of zigzag arrays 1. So we are given three integers n, l, r. Zigzag array of length n is defined as follows. Each element lies in range l, r. No two adjacent elements are equal. And no three elements form a strictly increasing or strictly decreasing sequence. Return the total number of zigzag arrays modulo 10 to 9 plus 7. Okay, so important thing, what are constraints, right? What is LR, what is N? And looks like we got N is 3 to 2000 and LR is 2000, which should tell you that you want to do N times number, right? And what could we do N times number? Well, we could have number of zigzag subsequences of length I, where last element is x, and last element is x. But the problem is we this way, so then we try all. Okay, but and then technically, because you don't know whether even if the last number is smaller, you cannot, or previous number is smaller, you cannot probably maybe take it if its previous number was smaller, right? So we also have to keep the direction it went, right? So we could only add like direction going down, right? So we'll have some sort of a dp ij01 is num of zigzags of length I ending in j with last two nums being decreasing, dpij1 same but last two nums increasing. Okay, and then we need recurrence and we need base cases. Both will be a bit tough, I think. Because okay, I mean, because if we have just one, if we have two, right, then we don't kind of care. And what I would do is base cases, let's call this state, and then base cases. So I would say dp0 with L to R 0/1 are all one way, right? Meaning that for all numbers from L to R, I mean, doesn't matter if we get increasing, decreasing. And then we do else 0, so boom, 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 boom. Transitions. Okay, and then so for transitions we want, okay, we are at some dpij0, right? And it could be like, because we pretend we want to go down, right? So j is, if it's 0, then j is less than the previous number. So then we do dp transitions I over 0. So it's dpk, and this is like sum over k is j plus 1 to r, and then it's like sum dpik and increasing, and then dpij0 is sum of k equals to l L through j minus 1 dpi minus 1 k, decreasing because here we want to be increasing. Now problem is, you can see we have n squared. Let's pretend r minus l is n, so we have two n squared states, and for each of them we are doing on transitions, so that's disgusting. But so let's say for j equal to 10 we sum from L to 9, and for j equal to 11 we sum, we just have to keep prefix sums basically for both, so that shouldn't be very difficult. And then we can also notice that optimization dpi only depends on dpi minus 1, can reduce space from n r minus l to just r minus l. So let's try to do that. So 0 m is r minus l plus 1, so we get 4i in range, and this should be 0 0, and then 4x in range lr plus 1 dp should be m, right? And then dp, is it technically 1 everywhere? I guess it is. And then we do like ndp 0 0, right? And then we go, so we do it in, so let's do prefix, and then we go 4j in range m, and then ndpj 1 is equal to prefix plus equals dp dpj0, and then prefix 0 for j in range, and dpj0 is prefix, and then prefix plus equals dpj1 dp and dp and dp dp, and then we want sum over everything, so ans is this, mod is this, and then ans plus dp0 plus no dpi0 plus dpi1 percentage mod. Let's see. Damn, no way it will work. No way it will work, bro. There is no way it will work. That's weird, we get TLE with this time complexity. Maybe I can't do 2 passes. But here is the thing, like I mean, I can try C++, but probably won't pass. Const in the mod. I know why. Because I have to mod throughout, numbers will get too big, and then ref plus this percentage mod. Alrighty. Maybe the numbers get too big and Python is just slow with them. I mean, I doubt it, but nah, it's just slow. 483. It kind of sucks. But maybe I don't have to actually create. Hey, we pass. Let's go. Okay, and then maybe I can throw this out. Okay, that's even faster. Because I'm just assigning. I'm not adding, so I can always reuse it. Okay, now we are talking about. And this might be some other optimization. Maybe not doing 2 passes, that could technically speed it up. Because if ndpj1 is sum of zeros, then in the next iteration and we are doing some of that. Yeah. Okay, let's pretend this is good enough. N times m om. Solutions. And this is just AI generated garbage from Indians. Oli. Number of what? Number of ZigZag arrays ending at I guess, I mean, makes sense that you can do DP on the other part. I'm surprised actually that I got this, to be honest, but 2D okay, so let n r minus l, then dp ij 0 is number of zigzags ending with j and I minus 1 element being larger than j. dpi1 is same thing, but I minus 1 element is smaller than j. Base cases, we see that n nm is roughly 10 to 6, which is usually the ceiling for passing the time limit, so we want some 2D dp. Base cases are dp0, j 0, 1 for all j from note that values of j don't have to go from L to R, rather only from 0 to R minus L. Base cases are for all j from 0 to m. dpij0 is sum k j plus 1 L dots m dp I minus 1 k 1 since we can go down to j by going up to sum k over j. dpij1 sum k 0 L dots j minus 1 dpi minus 1 k 0 can go up to since we can go down by going, since we can go up to j by going down, so I just put this into quotation marks, to sum k okay. Notice that the sum just it's dpik or like dpij minus 1, 0 when we move to dpi plus 1. We can maintain prefix slash suffix, we can maintain prefix and suffix sum for the second sum. So this is first sum, so we can maintain prefix and suffix. So when we to have second optimization, notice that dpi minus 1 only depends on values from dpi, so we can reduce the space complexity from state since we reduce the space okay, not horrific, I would say. Like 40 minutes for a hard problem is damn good. Okay, see you tomorrow. Bye.